Okay, so we're doing section 5.2 on the properties of rational exponents. It's a review from Algebra 1, so I'm going to go through it quickly. If you'd like to see a little bit more work on it, you can watch my Algebra 1 videos. It's in chapter 6, so 6.1, 6.2, 6.3 for Algebra 1. Okay, first one, product of powers. When you multiply two numbers, and the bases are the same, they have to be the same, all you do is simply add the exponents. So even if it's a rational exponent, which means it's a fraction, you just add it, just like you would normal fractions. Okay, power to a power, same thing. If there's parentheses here and it's power to a power, you're going to multiply it. Again, if it's a fraction, don't be afraid of it. 5/2 times 2, the 2's cancel out, so it's to the 5th power. I know that this is a little blurry in my video. You can take a look at it on page 244 in your book. In fact, I would probably pause the video and I would copy the chart down, or I think it's in your journal. You may want to cut it out and glue it into your journal. Negative exponent. This is the biggest thing. Negative exponent does not make the problem negative. The negative exponent is simply a direction that tells you to flip it into its reciprocal. So you either are going to move it down to the denominator or you're going to move it up. So the example here is 36 to negative 1/2 means to turn it into the reciprocal, and the 1/2 is really the square root. So the square root of 36 is 6. Zero exponent, easiest one in the entire world. Anything to the 0 power is always 1. You just have to memorize that. 1,000,000 to the 0 power is 1. Z to the 0 power is 1. You just have to memorize that. Quotient, dividing it. The shortcut for dividing it is that you subtract it. Again, the bases have to be the same. Power of a quotient. So if the entire thing is to a power, that power is given. It's not distributed. Don't use that vocabulary word. That's not the proper vocabulary word, but it's given to each of the terms. So it's given to the numerator, and then it's to the denominator, and then you solve it. So a common mistake is that kids are going to want to multiply 5 and 7 together, which you cannot do because they're not the same. So it's a power to a power, so let's multiply that. So this is 5 to the 3/3 times 7 to the 3/4. Good. 5 to the 3/3 is really 5, good, times 7 to the 3/4. And that's it. So the core concept on the property of the radicals, you've seen this from Algebra 1. This is pretty simple to understand. So if the radical is over an entire, like 2 different numbers, it is okay to split them. So the radical of the square root of a times b is the same as the square root of a times the square root of b. Same thing for the quotient property for division. If it is a giant division sign, or radical sign, I'm sorry, over a fraction, you can split it. So the square root of a divided by b is the same as the square root of a divided by the square root of b. Pretty simple. Monitoring Progress 5, there's different approaches depending on how you see it. Some kids will want to multiply it because it's the same root, so it's okay to multiply this. If you do multiply it, it would be the 4th root of 81. Good. And the 4th root of 81 is 3. The way that I see it this way. I know that 27 is 3 to the 3rd power. Then I know that when I multiply, I'm going to add them. So it's actually 3 to the 4th power. And then the powers are the same, so it just pops out, and the answer is 3. Either way, you'll come up with the same answer. Okay, let's look at Monitoring Progress 6. It has the same roots, so then I could divide this. So this is really the cube root of 125. And what's the cube root of 125? 5. Good job. So I own mistakes when I make them. Not a problem. It happens. All of us. It happens to everybody. When I initially had tried this, and I'm going to rationalize the denominator, I was thinking about square roots. But it's not square roots anymore because it's not just algebra 1. We're moving on to algebra 2. So this is the fifth root. So let's try this again. We're still going to break it up. Now, here's what you have to think. What number becomes a whole number when it's the fifth root? So you have to think of the very first number. And this only comes with experience. So the first number I'm going to start is 2. So 2 times 2 times 2 times 2 times 2. 5 times. What number is that? 32. So I'm going to want to force this number to be a perfect fifth root. And the closest perfect fifth root is 32. So what am I going to multiply 4 by to get 32? Good. So I'm going to multiply it by the fifth root of 8 in the form of 1, like we talked about. Now the fifth root of 8, let's now multiply across. Let's do the denominator. 4 times 8 is 32. This is now the fifth root of 3 times 8, which is 24. From experience, hopefully soon enough, you'll know the fifth root of 32 is really 2. And there is no whole number fifth root of 24. And that's how you're going to leave it. So you have to rationalize the denominator because you don't want to have a radical sign in the denominator. And this is where you have to stop and think, okay, what do I need to multiply this by so that I get a perfect fifth root? And that the closest fifth root here would be 32.